Hello everyone, I hope you are all doing well and catching up with all your courses and the requirements. I have sent you a message on Moodle. I was checking, I'm not sure if you have received it. Can you please let me know if you have received it concerning your midterm exam? So it's going to be Wednesday, April 15. Please, if you have received it, can one of you send me an email, okay, just to make sure that you have received it. So your exam is going to be next Wednesday. Basically, until now, I'm planning to do a multiple choice question exam. If not, if I want anything else, whenever I put it, I will inform you if it's gonna be more than multiple choice questions or not. So the material that's gonna include are everything until linked lists. So linked lists is not included. Um, uh, so basically, you're going to have a 1 hour examination or less. So I'm waiting to make sure, I'm waiting feedback from you to make sure that you have actually received this notification. Um, the assignments that you did, the work that you're doing based on the lectures, all of this is going to be to add up to your grade as well as the exam. So they are as important as the exam. So I want you to keep on working on your projects and in the lab, your assignments. Projects, what I mean, the assignments that you do based on the lectures. Now, what we have to talk about today, I'm going to only give you a short introduction on trees. Then we'll continue into different types of trees, binary search trees, AVL trees, and heaps. Why do we need to learn trees? Trees are another data structure that you need to learn because it's used a lot in computer engineering and computer science. It's used in most operating systems, for example, to organize the file systems. It's also used in searching, example, in searching algorithms, sorting algorithms, as well as many other algorithms are actually use data structures such as trees and graphs. So what is a tree? So as you can see, the tree, we always have a root node, which is the beginning of the tree, the root node, and it has children nodes. All right, so it can have 2 or more children, as you can see in this picture. However, let's say node B cannot be connected to node C like this. Okay, if it was connected, then it would be a graph. So what we will deal in this course are actually trees, in that a certain node is called a parent node, and it has children nodes. Okay, it can have as many children as it can. Okay, how much as much children as it wants, as there are. How many children are there? In this case, for example, A has 3 children. Okay, these are arranged in a linked list. So for every node, the pointers to the children are arranged in a linked list. So in A, it will have a linked list of its children. B will have a linked list of its children, and that's how a tree is created. So once you know the address of the root node, it's the same as having the address or the pointer to the first node in a stack or in a queue. We only needed a pointer to the first node. In here, we need a pointer to the root. Once you know the root, you can actually see, okay, you can actually reach to every node in the tree. There are some definitions that are specific to trees, let's say path to a node. So a path to a node, for example, a path to a node E, is actually the sequence of nodes that you have to traverse in order to arrive to E. So for example, to arrive to E, you start from the root. Okay, always starting from the root. So from the root, okay, we've got the child, which is the first child, which is B, and the first child of B is E. And that's what I mean by here, A, B, E. This is the path to the node E. And for every node, there is only one path. So this is called a path to a node because every node has to be reachable. The depth of a node is the length of the unique path from the node to this node. Okay. So for example, the depth of E is 2, the depth of A is 0. All right. So the depth to reach E, you have to go through A and B, and this is called the depth of E on the depth of any node. So the depth of B would be 1, the depth of A would be 0. Leaves, what are leaves? Leaves are those nodes which have no children. So they are without children, so these we call leaves. So leaves are node of the tree that have no children. The height of a node is the length of the longest path from the node to a leaf. This is called the height. So the height is like the opposite of the depth. So we need to know that at the top are the parents, at the bottom are the children. This is called the root. This is called the path. This is a leaf. This is called the subtree. Okay, as you can see, there are no links across the tree. The links always go down. Okay, that's why it's called a tree. And you have the different levels which indicate the height or the depth. And this is called the breadth. The breadth is horizontally how many nodes you have. Let's say, for example, 4. So this is called the breadth of the tree. Nodes that appear like this are called siblings. Siblings as being on the same level. All right. An application of trees, for example, is the file system. The file system in Unix, you have the root file system, and all the files are organized in it. So every node has one or more elements, as you can see. So this is the directory example. Element of a node is the name of the corresponding directory. So as if we're saying that every node, okay, is actually the name of the directory. We always implement trees using pointers, as we said. So each node has its children arranged in a linked list. So for example, A has a pointer to B, C, D. B has pointers to E and its children and its other children. So B has a pointer to E and this node. Yeah, E doesn't have any pointers, as we said. So again, this is, I told you, trees are used vigorously in data science and in data structures and in computer engineering. An example is the Unix directory system, for those who are familiar with it, and you will take it with in the operating system course. So this is the user is the root. You always have the user root, and all the files are arranged under it within the user root. And yeah, and each file has also more files, and each directory has another directory maybe, and then there are the files. So this is the directory that organization in the Unix operating system. I'm not gonna give you any more because I will continue this next time. What I want from you is to actually concentrate on studying the material for next week. I'm waiting for your feedback on the exam and whatever you have, whatever questions you have. All right, so waiting for your feedback.